In this video, we'll solve some conceptual problems on product of vectors. Here's a list of 6 questions. Alright, now pause the video, read them out, and see if you can answer each of them. And then we'll solve them together. Okay, let's look at them one by one. The first question says, if a vector dot a vector is equal to 0 and a vector dot b vector equals to 0, if both of these things are true, then what can we say about b vector? So let's think about it. A vector dot a vector equals to 0 means mod of a square, that's equal to 0. Because the angle between a and a, that's the same vector, that's 0. Cos of 0 is 1. So this dot product becomes mod of a times mod of a. So that's mod of a square. So if the dot product with itself is 0, this means the mod square is 0. This means the mod is 0. What this means is a is a 0 vector. The magnitude of a is actually 0. Now if you multiply a 0 vector, if you take the dot product of a 0 vector with any other vector, you'll still get a 0 vector. So a dot b will always be 0 for all values of b. Because a dot b is going to be mod of a times mod of b times cos of theta. And mod of a will always be 0. So this thing will always be 0 for all values of b. So what can we say about b? Well, nothing much. This is the same as asking, what can we say about x if 0 times x is equal to 0? Well, this is always going to be 0. So we can't say anything about x. Alright, let's move to the next one. If either vector a equals to 0 or b equals to 0, then a dot b equals to 0. That makes sense. If either vector a equals to 0 or b equals to 0, then their dot product is 0. And that makes sense. If you have 0 vectors, then their magnitude is 0. And if you take the dot product, you'll get 0. But the converse need not be true. Justify our answer with an example. So let's think about it. What this is saying is, if you have one of them as 0 vectors, then the dot product is 0. But if you have a dot product equals to 0, then this may or may not be true. The converse need not be true. So how do we explain this? Well, if you write dot product as this, a vector dot b vector, that's equal to mod of a, mod of b, cos of theta, you actually see 3 terms. The first 2 are magnitudes, but the third one is the cos of the angle between them. So if the dot product is 0, any one of them could be 0. Either mod of a could be 0 or mod of b could be 0. And if both of them are not 0, we can still have the dot product 0 if our cos theta is 0. So cos theta equal to 0 also makes the dot product 0, which means the converse is not true. We can have a dot product 0 with cos of theta equals to 0. And when does that happen? Cos theta equals to 0 at theta equals to pi by 2, which means this happens for perpendicular vectors. So if we have 2 vectors which are non-zero and they're perpendicular to each other, then their dot product will always be 0. So here's an example, I cap dot j cap, both of them are non-zero. So mod of I cap times mod of j cap times cos of pi by 2, which is the angle between them. This makes this dot product 0. Let's look at the next one. This says if a vector dot b vector equals to 0 and a vector cross b vector equals to 0, so both the dot product and the cross product are both 0. So what can we say about a and b? So let's think about it. Okay, a vector dot b vector equals to 0. That means mod of a times mod of b times cos of theta, that's equal to 0. And a vector cross b vector is also 0. So this means mod of a times mod of b times sine theta times the unit vector perpendicular to a and b, this entire thing is 0. So that's a 0 vector. So what can we say about a and b? Now we've just seen the dot product. This becomes 0 if any of these 3 things is 0. Either the magnitudes are 0 or cos of theta equals to 0. For the cross product, we can apply the same logic. Any 4 of these things could be 0. Well, this 4th one, this unit vector, can never be 0 because as the name suggests, this is the unit vector, its magnitude is 1. So for this to be 0, we'll have these 3 things, mod of a, mod of b and sine of theta. Either one of these could be 0 and we'll have a cross product equal to 0. So what's happening when both of these are together 0? Can we have both of them 0 with non-zero vectors? Think about it. If mod of a and mod of b are both non-zero, can we still have both of them equal to 0? For that to happen, cos theta should be 0 and sin theta should be 0. And that can't happen. there's no angle for which both sine and cos are together 0. So what we can say is both sine theta equal to 0 and cos theta equal to 0 can't be true together. So both of them can't be 0 together. This means for us to make both of them equal to 0, the dot product and the cross product, at least one of these magnitudes has to be 0. So at least one of the vectors is a 0 vector. Either A is a 0 vector or B is a 0 vector. Only in this scenario can we have both the dot product and the cross product together 0. Let's look at the next one. If either vector A equals to 0 or B equals to 0, then we have their cross product equal to 0. And that makes sense. Then one of them could be 0 and the cross product becomes 0. But the converse need not be true. Justify our answer with an example. We have just seen this scenario. If this thing is 0, if mod of A times mod of B times sine of theta, if this is 0, then any one of these three could be 0. We can still make this 0 with non-zero vectors. How can we do that? Well, we can make sine theta equal to 0. And when is sine theta equal to 0? That's when theta equals to 0. So we can do this for collinear vectors. Here's an example. I cross I, both of them are non-zero. Their cross product is still 0. Why is that so? Because the sign of 0 is making this entire thing equal to 0. Alright, now let's look at these two. If A vector equals to B vector plus C vector, so A is the sum of B and C, then is it true that mod of A equals to mod of B plus mod of C? Can we add their magnitudes to get the magnitude of A? Let's think about it. For this to be true, what this means is we have the sum of these vectors. A vector is B plus C. So mod of B plus C, that's equal to mod of B plus mod of C. Let's try visualizing these two vectors. If we have two vectors B and C, let's say we put them here like this. This yellow one is B vector and this blue one is C vector. Where's B plus C? By triangle law of addition, B plus C is this one, this orange vector. Now let's look at the magnitudes, which means let's look at the sides of this triangle. We can see that the sum of these two sides is always greater than this third side, which means the magnitude of B plus magnitude of C will always be greater than or equal to the magnitude of B plus C. So this is not always true. In fact, we have just seen the scenario where this is definitely not true. So this could be true, but it's not always true. And when will it be true? This will be true when the triangle collapses, when both of these vectors are facing in the same direction. That's when this yellow length plus blue length will be equal to this orange length. So this is not true, but this could be true when the triangle collapses, which means when B and C are facing in the same direction. Let's look at the last one. For what values of the angle between A and B do we have mod of A dot B equals to mod of A cross B? And in this case, we are taking non-zero vectors A and B. So now we have to make the dot product, the magnitude of the dot product, equal to the magnitude of the cross product. For what angle between A and B is this happening? Let's think about it. So mod of A dot B, that's mod of A, mod of B, and because we're taking the magnitude, we'll have mod of cos theta, we'll take the positive value. That's equal to mod of A cross B, so that's mod of A, mod of B, and mod of sine theta. N cap, the perpendicular vector, will have the magnitude 1, so we can ignore it. So these two things are equal and A and B are non-zero. So we can cancel mod of A and mod of B from both sides. What we'll have is mod of cos theta equals to mod of sine theta. So the magnitude of cos theta is same as the magnitude of sine theta. And that happens when theta is at pi by 4, when both of them are equal, or when both of them are opposite of each other, when both of them are negative, that's when theta is 3 pi by 4. So 45 degrees and 135 degrees, these are the two angles where we have mod of cos theta equal to mod of sine theta. For pi by 4, we have both of them equal to 1 by root 2. For 3 pi by 4, we'll have sine of 3 pi by 4 as 1 by root 2 and cos 3 pi by 4 as minus 1 by root 2. But their magnitudes will be equal because we'll take the positive values.